Hello friends, I welcome you all to this lecture on C programming. So in the previous lecture, I was supposed to tell you about that how to find roots of any equation, whether it is some polynomial or some transcendental equation with the help of loop. But I thought that it is better to tell you about functions so that we can bundle those equation into functions and then use those functions into our main program. So the task here is to find the root of any equation. So how to do that? We will be doing this with the help of algorithm known as Newton-Raphson. So how this thing works? So let's say that this is my curve for that function. What I'll do is I will start with some guess value. Let's say this is the 1. Then what I'll do is I will draw a tangent from this point, and let's say that the tangent intersect at point xn. So based on the coordinates, that is xn comma 0 and this one, that is xg comma fxg, I should be able to find the equation of a line containing the slope. So what it will become? So the new value will become the guess value minus fx guess by f prime x guess. This is a very simple equation. What you can do is you just have to find the equation of a line. That's it. Now once this is done, then you do what? Then you find the absolute error between the new value and the guess value. If that, let's say it is error, if this error is less than, if the error is less than some uh, tolerance criteria, let's say 10 to the power minus 4, then your xn is the answer. And if it happens that it is not, then do what? Then you simply say that the guess for the next iteration will be the one which I have obtained, and then directly go to this step and repeat this continuously till the error is this. Now, how to do this? Very simple thing. So for that matter, first I should have some equation. So let us do what? Let us take one function, that is x square minus 5x plus 6. So you know the roots are 2 and 3. So I am interested in finding out the roots of this equation. So first I will make this function x square minus 5x plus 6. So how to write a function now, you know. So remember, all the mathematical functions normally are float. So they will be returning float. So let us say this. So let my function name is f, and this is taking one argument x. So you know that this x has to be defined. That means the data type. So let's say it is float. Once this is done, then what you have to do is you have to write equation and return it. Simply say return, then that is x square. So return, so it is x square, and then it was minus 5x, then plus 6. That's it. This is your equation. Okay, so now let's say that I am interested in the roots. So the formula says, the procedure says you first have this guess. Okay, so let us start with it. Let's declare float x guess as, let's say the starting value I am taking as 0. Now 0 will be close to which root? So 2, 3, 2. So in this case I should get 2 as my answer. Then what I have to do? Then I have to take one more variable, let's say error, and assign this something which is more, let's say 10. More than what? Terminating criteria. What was my terminating criteria? It was 10 to the power minus 4. Okay, then what? Then while the error is more than 10 to the power minus 4, repeat this. Repeat what? What you have to do is you have to find the new value, that is x guess minus the function you have developed, it is f. So it is f x guess, then divided by, look here, it is f prime. So we have to find prime also. So here, what is the prime? So let us copy this function and make it, let's say that prime is underscore p. So f underscore p means prime. So if I differentiate it, this is x square, so it will become 2x. So it is 2 times x, and this is minus 5x, so it will become minus 5, and this is 6, so it will become 0. So once you differentiate this, you will be getting this. Now you will be f prime, what was it, f prime p, and then you pass this. Once this is done, then you are having not only guess but also new. Then you find out the error. So it is nothing but the absolute f that means absolute value of xn minus x guess. Once this is done, then what you have to do, you have to update the value of guess by new value, and this program will continuously do the task. So what I'll do here, printf percentage f comma, I will be printing what is the error for that iteration. I have to declare one variable for counting how many iterations it has taken so far. So here I have not declared the error, so it is float type, and at the same time one should also know that how many iterations the program is taking. So int, so let's say I is that counter which is starting with 1, and I have to print this I also. So I is assigned percentage d, and let me write it, error is equal to, so this will be I comma error, and what else I have to do, I have to increment this counter. Once I done this, I think I have done it correctly. So if I run it, so it is having some problem. What is the problem? What it say? Xn undeclared. Oh, I have not declared xn. So let us say xn I am declaring outside. So xn, and if I run it now, it will say that the program is converging in 6 iterations. So let me write it correctly. So every line, new line. So that is how it is working. So first iteration error was 1.2, second it is 0.55, third it is 0.2, and then, so how it works? It works basically, once you know the new value, it will again move and evaluate the slope here. So whatsoever the slope it will be, so this will be my new value, and then it will become the guess for the next iteration. It will go here and then again draw a tangent, and in this way this reaches the root, and that is what is happening in the program itself. So if you look, that is what is happening. So what is your answer? My root will be the new value, the final new value. So printf percentage d, root is, sorry, percentage f, and that is nothing but your x new. So if you run this, so the root is coming out to be 2. This is what we have expected because the initial guess was close to 0. The second root will be 3. So let's say I'm starting with a huge number, let's say 30, and then I check whether it reaches to that value 3 or not, and if it reaches, then in how many steps. So if I run this, so it has reached that 3 as the root, and it has taken 9. So the more farther you go away from the root, so if I make it 300, the more number of iterations that will take to arrive at that answer. So friends, in this way you can use your while loop to find the roots of any equation, whether it is polynomial or transcendental equation, and that's it. Let us take one more problem. Let's say the function which I want to find the roots of is nothing but, let's say, sine theta minus theta square plus theta plus 5. So sine theta minus theta square, or in place of theta you can say sine x plus x square, this. Now this is a transcendental equation and it becomes very difficult for me to find out the value of x. But no problem, we have Newton-Raphson. Just remember sine x minus x square plus x plus 5. So in place of function, what I have to write, sine x plus, is it plus or minus? Minus x square minus x square, then plus x and then plus 5. Am I right? Okay. And I am interested in finding out the root. So I have to find out its derivative. So what is the derivative of sine x? It is cos x. Then what is the derivative of x square? It is minus, so it is 2x basically. So minus was there, so it is 2x. And then derivative of x is 1, derivative of 5 is 0. Let us start with our original guess, that is 0. And let us see that in how many iterations the result comes. Oh, the result has come only in 5 iterations. This is a very fast algorithm to check whether how many roots or what is the root. So in this way, you look, it was a very difficult problem if you solve it using pen and paper, but using the numerical computation, you are able to do it so easily. So in this way, friends, we can find out the roots of any equation, whether it is polynomial or transcendental equation. So in this lecture, till this point only. In the next lecture, I will be telling you how to use the while loop to find out the solution for system of linear equations. And this time what we'll be doing is we will be using a method called as Gauss Seidel, very powerful method, but it only works when the problem is diagonally dominant. I'll explain everything there. Okay, so thank you very much for watching it.